Right, continuing on. Here we're looking at 2004 question 7, like a typical question 8. So copy into your answer book the structure below for the ester shown and indicate clearly on your diagram a carbon atom which is in planar geometry in the molecule and also a carbon which is tetrahedral. So I don't like the way it's initially drawn like that. I would split that up. So H3C becomes CH3, CH2, C double bond O. Make it more familiar looking to yourself. O, CH3. Them two are the same molecules. And now it looks a lot nicer, a lot more appealing to us. Now planar means it's got a double or a triple bond. So there's my planar carbon there of your carbonyl group. Now tetrahedral just means singly bonded, so you can pick that one, or that one. There's 3 tetrahedral carbons there. Give the name of the alcohol and of the carboxylic acid from which the ester is shown. Now this is in your section on reaction mechanisms. Now what you need to know is an acid, which is a carboxylic acid in this case, and an alcohol always react to give you an ester in water. Now they've given me the formula for the ester from the structural formula. So it's CH3, CH2, just going from left to right, CH3, CH2, COO, CH3, plus my water, H2O, or for this case, it's very often handier to write HOH. Now you just work back, keeping in mind that your functional group of your carboxylic acid is COH. So just go from left to right, CH3, CH2, COO, H, plus my CH3, OH. So give the names of the alcohol and the carboxylic acid. So I'm going to draw these out. So there's my CH3, CH2, C double bond O, OH. And if I was naming that fella, metheth prop anoic acid. My alcohol, CH3, OH, is methanol. So give the names of the alcohol and of the carboxylic acid from which the ester shown and synthesized. What organic reaction type describes the esterification reaction? So it's a substitution reaction. You know, your hydrogen of your carboxylic acid is being replaced there by an alkyl group like your CH3. So your reaction type is substitution. C. The carboxylic acid you are asked to name in B, which is my propanoic acid, may itself be synthesized in 2 steps from an alcohol. Now once I see that, I'm initially thinking of these letters. PAC, you know, your primary alcohol to your aldehyde to your carboxylic acid. 2-pack. So the first thing there, identify the alcohol from which the carboxylic acid is derived. Now that is a primary alcohol. How do I make propanoic acid? I use propanol. Now as it's a primary alcohol, I've got to put in that one, propan 1-ol. Let's just remember how many carbons are bonded to your hydroxyl group. Give the name and structure of the intermediate organic in this. So this is my intermediate, my aldehyde in between. So it's your primary alcohol to your aldehyde, it's propanal. And the structure, meth, eth, prop, your carbonyl group at the end, fill up the rest with hydrogens. And identify the type of organic reaction type involved in each step. When I'm going this direction here, that's oxidation. And identify the organic reagents which may be used. So when I'm carrying out that oxidation, I use acidified KMnO4, potassium manganate 7. And I'm just going to squeeze in here the last bit. 2 common uses of esters. Any organic substance, you could nearly have a guess, you could say solvents. Now esters also have a characteristic nice smell, so you could say in perfumes, a mandatory experiment we looked at, soap making, flavorings in food, and so on. And I'll do one other one. 2003 question 6. So again, your question 6 nowadays is your fuels. back then, they could have been anywhere. So it's your typical question 8, as I would say now. So 2003, question 6. So study the reaction scheme and answer the questions which follow. Which of the compounds has no tetrahedrally bonded carbons? And I often say in these, draw out the things before you even get started. So A is C2H4. I know that's ethene. C double bond C H4. Takes no time at all to draw them out. B is C2H6. And C is C2H5Cl. Now, which of the compounds has no tetrahedrally bonded carbon atoms? So which one has no singly bonded carbon atoms? Now we can see they're full of tetrahedral carbons. So the one which doesn't is A. They're both planar. It's a double bond. It's an unsaturated compound. So A or ethene or C2H4, whatever way you want to refer to it as. I suppose it did ask me which of them A, B or C, so we'll say A. Draw the structure of the molecule of this compound. I'll just draw it again, keeping everything in the right position. There we go. Classify the conversion X, Y, and Z as addition, substitution, and elimination. Now take your time in these. A, we're going from C2H4 to C2H5Cl. Now it doesn't matter what I'm forming in that. Once I see that there's an alkene, all alkenes react by addition. Every single alkene, sorry I went down to Y, first it's all the same, therefore Y is addition. All alkenes react by addition. The other one in my X is C2H4 to C2H6. Again, I'm starting there with an alkene. Therefore, all alkenes react by addition. They add across that electron-rich double bond you have been told. And then your last one, Z, you're going from C2H6, which is your ethane, which we drew there, and C2H5Cl. Now this doesn't have any room to add on anything else. So this is my alkane, and all alkanes react by substitution. So there we go. So X and Y is addition, Z is substitution. Elimination is just when I've got my alcohol and going back to my alkene, when I'm removing something. C. What reagent is used to convert A to C? So here once again I'm going from my C2H4 to my C2H5Cl. So what reagent? How I'm going by addition, and what am I adding on to this? I'm adding on a hydrogen and I'm adding on a Cl. So I can just simply add on. There's no substitution take place. So what reagent? My reagent is HCl. Now, if you're unsure what you call that, that's actually hydrogen chloride in that sense. Don't call it the other thing. So play it safe and just say HCl, unless it said name. D. What reagent or what conditions are required for B to C? So this is my B to C. My ethane to chloroethane. Now ethane's an alkane, reacts by substitution, free radical substitution. And for free radical substitution, that involved your UV light. The clue is there, reagent and conditions. So my reagent is chlorine. And my conditions, it's like a double header there. I need my ultraviolet light. And describe the mechanism to go from A to C. A to C once again was this. This is my ionic addition mechanism. Now I'll not write out all the words to it. But take your time. Don't be doing substitution here. It's an alkene. Alkenes react by addition. So here you've got your ethane. I'll just draw the pictures. You've got your electron-rich double bond. We looked at the addition of chlorine the addition of bromine for my bridged intermediate, and the addition of HCl, which is this one, hydrogen chloride. Now the difference in this, there's no polarization of the bonds because there's already an electronegativity difference in it. Cl, sorry, minus. Now your positive one always does the attacking first because this is a rich area of negative charge. So your positive one, which is my hydrogen, is going to go straight on first of all. Now when that attaches on, it draws the electrons away from this carbon, creating what's known as a carbonium ion down there. Now that's difficult. So for both your chlorine and for your addition of HCl, you get a carbonium ion. I have my Cl minus floating about. The next step then, it's going to come in from the opposite side. Your opposite charges attracting each other. Going to swoop in around from the opposite side, and this results in the formation of chloroethane. Now put words to that. I probably even could have done another step here in which that's swooping around, but limited in space for this thing here. And it does say what piece of experimental evidence supports the mechanism. The thing about your ionic addition mechanisms, the wee bit of evidence in that is if it was carried out in salty water, if addition mechanism, so it doesn't matter for which one. So you just have to learn these mechanisms out. It was carried out in salty water, so that's Na plus Cl minus and H plus OH minus. You know, you're thinking of those. You get different negative ions going on to it. So you might have ethanol being formed instead of chloroethane, resulting in different products. Such as, so my OH minus, my hydroxyl group, my hydroxide ion, suppose, is going instead of my Cl minus. So I'd have an OH in there, and I'd get ethanol, such as ethanol. Something like that. Right, that's those two done.